When you think about the future of aviation, cleaner, faster, more efficient flight, you're probably picturing some futuristic lab, right? But what if I told you the answer isn't being invented, but rediscovered? That it's already been perfected over 400 million years by one of the ocean's oldest predators? Yeah, today we're talking about how the shark is helping us solve one of engineering's biggest problems. To really get why this is such a big deal, we have to ask a simple question first. What is the single biggest enemy of everything that flies? Seriously, take a second. What's that one constant, invisible battle being fought on every single flight? It's not turbulence. It's not even gravity. It's an invisible force called drag. Drag is relentless. It's the resistance that slows everything down. It burns through billions of dollars in fuel, and it has a massive impact on our planet. So this invisible enemy, this force of drag, is what engineers have been battling since the Wright brothers first took off. And while we've made incredible strides, the next big leap forward might not come from a new engine, but from the skin of the aircraft itself. And that brings us to our very unlikely hero, the shark. I mean, think about it. Nature's own R&D department has spent millions and millions of years refining this animal into the perfect swimming machine. And it turns out, it solved the drag problem a long, long time ago. For the longest time, our logic just seemed, well, logical. To move through air or water with the least resistance, a surface should be as smooth as possible, right? Like glass smooth. You think of a polished race car or a sleek jet. It just makes intuitive sense. But nature, it turns out, had a pretty counterintuitive trick up its sleeve. And here's the big twist. When scientists looked closer, they discovered a shark's skin isn't smooth at all, not even close. In fact, it's the very specific roughness of their skin that makes them so incredibly efficient. This discovery just completely flipped our old assumptions on their head. So what is this roughness? It comes from millions of these things, dermal denticles. The name literally means skin teeth, and honestly, that's the perfect description. There are these tiny V-shaped scales with the same basic structure as our teeth, complete with dentin and enamel. They are the biological marvel behind the shark's silent, deadly glide. So how on earth does a rough, tooth-covered surface actually make something faster? It seems to defy logic, but the physics behind it is absolutely brilliant. To get it, we need to know there are two main types of drag. You've got pressure drag, which is all about the object's shape. We solve that by making planes streamlined. But then, there's skin friction drag. This one's different. It's caused by the air literally sticking to and rubbing against the plane's surface. And here's the crucial part. For a modern jet, this skin friction accounts for almost half of all the drag it experiences. And this is where the magic happens. As air flows over a surface, it gets all turbulent right near the skin, forming these tiny, chaotic swirls called vortices. Those vortices create friction, but the shark's skin teeth have microscopic grooves, or riblets, that act like tiny little fences. They disrupt these vortices, stop them from moving side to side, and keep them away from the skin. This creates a kind of low-friction buffer zone, letting the shark, or the airplane, slip through the air with way less resistance. Okay, so taking this amazing principle from nature and actually applying it to a 200-foot-long commercial airplane, well, that's a massive leap in engineering. How do you do it? The answer for now is a really high-tech film. Companies like Lufthansa Technik have developed a product called AeroSHARK. It's a transparent adhesive film that's been embossed with millions of these microscopic ridges. And when I say microscopic, I mean it. Each ridge is only 50 micrometers high. That is about half the thickness of a single human hair. Now I know what you might be thinking. A fancy sticker on a plane, how much of a difference can that really make? Well, in the world of aviation, even the tiniest improvements can have absolutely enormous consequences. So when Lufthansa applied this AeroSHARK film to their fleet of Boeing 777 cargo jets, they measured a drag reduction of about 1.1%. And I know, that number sounds tiny, almost insignificant. But hold on, because this is where you really see the power of scale. That 1.1% reduction on a single plane saves 400 tons of jet fuel and prevents 1,200 tons of CO2 from entering the atmosphere every single year. Multiply that across an entire fleet, and you're suddenly talking about one of the most effective green technologies in aviation, one that actually pays for itself. And this isn't just for airplanes. The shark skin effect is a total game changer wherever fluid meets the surface. We're seeing it on the hulls of cargo ships to save fuel, on wind turbine blades to generate more power with less noise, and even in sports. Remember those controversial shark skin swimsuits from the Olympics? It's all the exact same principle. But just applying a film, well, that's just the beginning. The next evolution of this technology is even more incredible as we try to get closer to mimicking the living, breathing organism itself. Of course, there are challenges. These microscopic ridges are delicate. They can be worn down by ice and rain or clogged by dirt and insects, which pretty much negates the effect. And the process of applying the film to an entire aircraft is still slow and pretty expensive. And that's why the holy grail here is something called active skin. A real shark can actually bristle and flex its scales to adapt to changing currents. So the dream is to create smart materials for aircraft that can change their texture on the fly, optimizing for takeoff, cruise, and landing, just like a living creature. But before we know, there's one more amazing, unexpected benefit. The physical pattern of shark skin is naturally antibacterial. Microbes have a really hard time clinging to that surface, so they can't form colonies. This sharklet technology is now being used inside the cabin on high-touch surfaces like tray tables to create a more hygienic environment without using chemicals. How cool is that? So what does this all mean? Well, for decades, engineering was kind of about conquering nature. But this technology shows a profound shift. We're finally learning to listen, to observe, and to cooperate with the brilliant solutions that nature has been perfecting for hundreds of millions of years. The answer wasn't more power. It was better design, hiding in plain sight on the back of a shark. It just makes you wonder, what other secrets are waiting for us in the natural world, ready to solve our biggest challenges?